Okay, so let's look at example 1 continued and see if we can apply the same things that we talked about in the first example, as well as the characteristics of the parabolas we talked about in the previous videos. So in example 1 continued, they want us to graph and identify the focus, directrix, and axis of symmetry of x is equal to -1/8 y squared. So right off the bat, I know that we have a parabola because one of my variables is squared. That's my y squared. But I also know my first step is to get my equation in standard form. And in standard form, I know that my entire equation should have the squared variable by itself. So in this case, y is my squared variable. So because my variable y is squared, my axis of symmetry is obviously going to be opposite. So I know my axis of symmetry is going to be my x-axis. But again, that's not all that important to remember. So the first step to actually remember is we want to get it y squared by itself. So to do that, I've got a fraction here, and if you guys remember, to get rid of a fraction, you're going to multiply by its reciprocal, which in this case is 8/1. So if I multiply both sides by 8/1, or 8, I get -8x is equal to y squared. If I rewrite that and flip it the other way, I know y squared is equal to, -8x. So that's my standard form of that equation. Step 2 is taking my equation form and my actual form. Now remember, what I just changed around is my actual form. My equation form is the one from the previous page. So I'll flip it over again. The standard equation of parabolas. We have to pick the one that matches the situation we have. So since my y is squared, I'm going to pick this guy as my equation form. My equation form is y squared is equal to 4px. Okay? My actual form I found up here through a little bit of work. Y squared is equal to -8x. And I need to know my p-value because, again, my p-value tells me where my focus and directrix is because they're the same distance, right? They're the same units, but they're around my vertex. So I need to know what my p-value is. So if I circle these two, 4p and -8 are in the same position. So my y squareds are lined up on the left, my x's are lined up on my right. So 4 times what gives me -8? Or another way to do that is to set them equal to each other and solve for p. So if I divide both sides by 4, I get p is equal to -2. -2. Couple quick things that should be coming kind of a little bit more naturally to you as you start working on these problems is y is the variable that's squared. Therefore, your parabola is going to move around your y-axis. So around your y-axis, it slices your graph. Your y-axis slices your graph into a left and a right space, right? Just like your x-axis cuts your graph into a top and bottom space. So because my actual form starts with y squared, I know I'm going around my y-axis, so my y-axis is important. So it's either going to open up to the left or it's going to open up to the right depending on what my p-value is. And since my p-value is negative, I know it's going to open up to the left because out of my right and my left, these are positive x values, these are negative x values. So I want to make sure that if my p is negative, I know I'm going in the negative direction. Okay? So I know my vertex is at 0, 0. I also know that my p-value is negative, so I know I'm going to be opening a parabola to the left. Therefore, my focus, which is always inside my parabola, is going to be a point inside that I know that because my graph opens to the left, my focus has to be point on the left, on my x-axis, because my x-axis slices, will be my axis of symmetry, slices my graph in half. So if I'm plotting points over here, then I know my focus is going to be at p, 0, because I know if I were to plot this point on the left, that I have an x value but no y value. So my focus should be -2, 0. Which therefore means, so if I plot that, -2, 0, which would be there, I therefore know that my directrix is going to be equidistant in the opposite direction. But it's a line, right, that's going to be